percentile rank of a data value in a large distribution gives the percentage of data values that are below a given value. In the previous example, now we're not doing that one. Let's take a look at the data that we have down here. So the person who scored right here, person A, if 30% of the data is below them, below their score, they would be called the 30th percentile. Person B, however, scored better than 80% of the people, so they would be in the 80th percentile. Okay? So those are the examples that we see. Let's look at the problems on the next page. So, it says the following data represent the ages of family members attending a family reunion. I was just at a family reunion. That's a coincidence. Okay, so these are the ages of the people who were there. The question is, find the percentile rank of the 14-year-old. Question 1, here's what you need for percentile rank. How many people were there total? And then how many people are younger than the 14-year-old? That's how you get percentile rank. I'll pause the video while you calculate those two things. And we're back, and we've calculated that there are 24 people at the party. So out of the 24 people at the party, we found that 6 of them are younger than 14. 6 divided by 24 is 0.25. So the 14-year-old would be considered at the 25th percentile. Does everybody understand how to find percentile? How many are to the left or younger out of the total? Draw a histogram for these data with 9 bins. So again, I'll pause the video, but before we do that, let's get it set up. So to make a histogram, which you are going to have to do, you're going to need an x-axis and a y-axis. Okay? And we need to basically think about, for our histogram, how wide should the bins be if we want 9 of them? So what you want to do is, tell me what the minimum value is. How young is the youngest kid at the reunion? 0. Okay? So our histogram is going to go from 0 all the way up to how old? I see an 87-year-old there. So if we want the bins to be, if we want there to be 9 bins, what should the bin width be? So we can include everyone. How about 0 to 10, 11 to 20? Let's count. Will that be enough? 0 to 10, 11 to 20, right? 20 to 30, 30 to 40, 30, right? Will that be enough bins? We need 9 bins. You think that'll be good? I was going to count them all, but my tick marks are disappearing. So 0 to 10, 20, 30, 40. Will this work? 60, 70, 80, 90. That'll make 9 bins. 1, 2, 3, 4, 5, 6, 7, 8, 9. Will that include everyone? Will the 87-year-old be included in the histogram? Yes, because we went up to 90. Okay? So here's how we... No child gets left behind. That was a good point. That's a good one. So, here's what I'd like you to do to make a good histogram. Can you make X's? Do you have the ability to make X's when you draw? Okay. Put an X in each bin for each person. Try to make your X's uniform in size. So try to make your X's the same height. So the 9-year-old, boom, would go here. The 5-year-old would go here. So just go through and mark them and include them where they belong. The 25-year-old would be here. The reason that I want you to make your X's pretty much the same size is so that your bins are consistent in height. Okay? You don't want this to represent 2, and then over here, if you made your X bigger, here it represents 1. That doesn't make sense, right? You want it to be the right size for the number of people. Okay? So go through and make a histogram that includes everyone, and we'll be done with this problem. So we made part of the histogram here. I only graphed the first 6 people with these stars. And the only thing I wanted to mention before I stop the video is that this 40-year-old person went in this bin to the right of 40, between 40 and 50. That's really the only place you can mess up in making a histogram. Where do you put someone when they're on the boundary line? You put them in the next bin over to the right. Okay? So go ahead and complete that on your own, and we'll check it in class.